Alright, we're going to get into Chapter 8, or Unit 8, whichever way you want to take it. We're going to talk about rational functions, and rational means fractions. So everything's going to be shown to you as fractions. So that's kind of the key word of what we're doing. We're going to use a lot of prior knowledge. Other things, domain restriction. Remember, domain is the x values. And if you have a fraction, that means we can't divide by 0. So what would make it equal to 0 is what we're looking for. And that's what we have, just kind of textbook at the bottom. For rational functions, domain restrictions are those values that make the denominator 0. So that's what we're trying to find out. So the only thing that we care about is the denominator. So we're going to set it equal to 0, just like that. And then we're looking to find factors. Are there factors of 12 that subtract to give me 4? You betcha. Alright, x. That means it's 6 and 2. If we want positive 4, we're going to go with positive 6 and negative 2. So these are the factors. So one more step. Remember, a long time ago you set those equal to 0. You hardly do that anymore now, which is great. X is negative 6 and 2. But here's the thing. Since these are domain restrictions, that means x cannot be. Okay? That means x cannot be negative 6 or 2. So everything we solved for before is now going to become something that it cannot be anymore. So we've got a few slides just to practice that. Just getting our factors. Factors of 20 that add up to 9. So remember, the signs are to be the same this time. So minus 4 and minus 5. As we go to solve, we find out that x can be 4 or 5. But remember, what we're talking about is in the denominator. So x cannot be 4 or 5. Domain restrictions. Alright, double doozy here. Remember, we have a difference of 2 squares. Again, at this point in the chapter, we don't care about the numerator. We're just saying denominator. You can't be 0. So this is x plus 10 and x minus 10. So you know that x cannot be positive or negative 10. Domain restriction. In our next one, we now have this multiplier of 2 out in front, so we need to solve using that. So remember, we're going to factor by grouping, so we may have to draw a little arc over here. We're talking about the number 20, and it adds up to 9, so it's 4 and 5, so 2x squared plus 4x plus 5x plus 10. GCF is 2x, so x plus 2 gets left over. We need x plus 2 right away. That makes the GCF of 5x and 10 to be 5. So 2x plus 5 and x plus 2. Alright, these are the ones equal to 0. So x is not allowed to be negative 5 over 2 or negative 2. Again, domain restriction. So that's the only thing that's going to happen, is we're going to make this a value something more than 1, so our factoring is going to take a little bit more work. But we just talked about 20, 4 and 5. Remember, the order doesn't matter. Just be careful of your signs. Alright, to make some of that easier, we're just going to work with a GCF whenever we can. So the GCF here is 3x. So that means we have x plus 7 left over. And remember, if you have a plain old 3x, set it equal to 0. That means when you divide by 3, we're going to find out x cannot be 0. And we could also, why don't I just go ahead and erase the end of that box right there. And let's plug this guy in here as well. Negative 7. Okay, so that factoring out a variable is going to cause a 0. And hopefully this helps out here. We divide by 2. No x on the end, so I can't divide by 2x, but 2, so we get x squared minus 5x minus 24. Alright, so if it doesn't carry a variable, this we can just say we're going to divide it by 2, so we get rid of it. Alright, factors of 24 that are 5 apart. I believe that's 8 and 3. So minus 8 plus 3. So we're going to go with positive 8 and negative 3. And again, I always go back and say that is the 2 values that are domain restrictions. So look for a GCF anytime we can. Yeah, so that's how we find domain restrictions. Alright, so you want to make sure you go back and just think about what's going on here. So what's a rational function? How do we know it's a rational function? How do we find the domain restrictions? So what did we have to do there? And what prior skills are we using? So if you have any of that information in there, just think about what in the world we're doing. So you might want to pause here. Alright, so you didn't pause anything. Here we go. So how do we simplify the whole thing? So this is the task now. Say, okay, let's just simplify rational expressions. Well, we're going to identify domain restrictions. That's what we just did. To do that, we're going to factor out each piece completely. Okay, so now if I want to simplify it, we're not just in the denominator anymore, we're also in the numerator. And we want to cancel out any common factors. So that's going to go from top to bottom if we get anything. So that's what we want to be careful with as we proceed. Alright, so let's take a gander, see what we got here. Kids, denominator, I got an x and an x plus 4. And the numerator is just 5x. It's going to stay that way. So what things can cancel out here? Well, I can divide out an x with an x. So my final answer is just 5 over x plus 4. So this is the simplified version. We're still going to talk about and identify domain restrictions. So we're going to say, well, x cannot be 0 and negative 4. So even though it canceled out, we have to list the items that it cannot be anymore. Okay, so multiple parts to our answer. Simplify what we have, and then also the domain restrictions. Alright, not too shabby. Alright, hopefully I don't write too big here. We'll have this all covered up and created some awesome stuff. Alright, looking at the numerator, x plus 2, x minus 2. Not too bad, difference of squares. Okay, so if you're like, where'd that come from? And remember, we're just going to take the square root of each. In the denominator, I know I'm going to use 4 and 2. And we got x plus 4 and x minus 2. Now that it's all factored out, I can get rid of some things, like an x minus 2. That leaves my final answer. It's nice when it works out that I had them stacked up anyway, as x plus 2 over x plus 4. Where there's domain restrictions, x is not allowed to be negative 4 and positive 2. Again, even though it canceled out, we need to list those as domain restrictions. So it's just a ton of factoring over and over. As you can tell, this will be one of your most favorite lessons ever. And chapters. Alright, so here we are. We still have a ton of factoring we can do all over the place. Let's start in the numerator. All we have is a GCF. So 2, and I get 2x plus 3. Okay, I like when that happens. Let's just take a guess here and see if I can get my 2x plus 3 to work out again. So what would my other factor have to be? X, signs are the same, plus 1. Alright, now that's taking a complete guess, but often these things are going to match up. So let's just FOIL it real quick. On the outside I got 3x, and here I got 2x. That would give me 5 in the middle. Alright, so that works. So that's kind of where we want to be. So here's the upside of having so much work in each problem, is we're going to get some of those things as hints to what's going to happen. So final answer is just 2 over x plus 1. X cannot be, you are not allowed to be negative 1. And from our second one, we subtracted 3 and divided by 2. Those are my domain restrictions. Whoop whoop. Alright, difference of squares up top, so x plus 3 and x minus 3. And down below 12, they're 1 apart, that's 4 and 3. X and 4, x and 3, plus 4 and minus 3. As luck would have it, it looks like I wrote my x minus 3's on top of each other again. I'm doing pretty good. So we got x plus 3 over x plus 4, that's my final answer. Simplified rational expression. X, you are not allowed to be negative 4 or positive 3. Alright, what do we got going on here? probably something weird because it went back to 1 on this page, right? So let's see, 4x, you're going to stay 4x. 12x squared and 8x, you're both divisible by 4x. Okay, so that's the something weird, but it doesn't really look weird yet. 12 divided by 4, that's 3. There's still going to be an x plus 2. Still not too shabby. Well, I get it. We're going to cross these out, right? The 4 and the x. Huh, okay. So the answer is 3x plus 2, right? No. It's on the bottom. So if everything cancels out, whether it's top or bottom, 1 needs to hold that place. Okay, if it's in the bottom, we just don't write it. The 1, that is. If we have a 1 up top, so we can show that the part that's left over is from the denominator. So that's the key here, is the part that's left over is in the denominator. So I have to put this 1 in the numerator to show that it still exists in the bottom. Right. I feel like I rambled on there. I hope you get what I'm saying. Alright, domain restrictions, x you're not allowed to be 0. That's from the 4x. And negative 2/3. Domain restrictions. Alright, one more. I'm counting my slides just right here. Okay, GCF of 2. Oh man, there's so much to do in this problem. 2, what's left? X squared minus 10x plus 21. What do you think? Some kids like to just go ahead and finish the numerator. So we got an x minus 3 and an x minus 7. Because sometimes that's going to help out. The other one, oh man, we got 12. And we're trying to work that out to add up to 7, negative 4, and negative 3. 3x squared minus 4x minus 3x plus 4. Oh man, what's going to happen here? I don't know, I'm so scared. 3x minus 4. I need a 3x minus 4, so we're going to take out negative 1. And let's see what happens here. X minus 1 over top of 3x minus 4. Alright, so here's what we had. X minus 1, 3x minus 4. Well, I'll be to be get anything to match. No. Yeah. So based on whatever type of problem you're working with, that is your simplified answer. If they want it to be foiled back together, then it was simplified when we started, but we had no idea when we got started. Maybe you did. I didn't. Well, I kind of did. Alright, either way, domain restrictions. So it wasn't complete lost cause because I certainly can't tell the domain restrictions without factoring at least the bottom. So I got 1 and 4/3. Two separate answers. 1, the other answer 4/3. Domain restrictions, simplified version, either which way. Alright, so what did you think of this lesson? I don't know. I'm a little bit biased. I thought it was just right. Maybe too easy. Some problems too hard. Last problem was like, why'd we do all that? So I'm going to say just right, like Goldilocks would. Alright, now, you kind of worked pretty hard there, so I want to make sure I left a slide in there so you can draw a picture, whatever you want it to be. I know how much you guys like to do that. So take time, draw whatever you want. But I do have one more slide on the end, so any questions you have, I'll be able to see all your responses just to see what type of questions. So I'll either get back to you individually or just send something back out to the class as needed.